All right, so we talked about polynomials. We talked about reciprocal situations, right? Or kind of reciprocal modifications where you have a constant on top and a variable on the bottom to some power. Now let's talk about rational functions where we have a polynomial on top and a polynomial on the bottom, okay? So this is kind of our third case here we're dealing with limits to infinity, and this is our last case. But within this case, there's three scenarios, okay? So let me write these out right here. The first scenario is where you have some polynomial on top, let's say ax to the nth power, and then dot, 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 right? You have a bunch of stuff going on after that. Or, you don't even have to have anything going on after that, but you have some kind of monomial or polynomial on top. Then on the bottom, you have some kind of monomial or polynomial, okay, that has some stuff that comes after it. But once again, like we saw with the polynomials, we really are only concerned about those leading coefficients and leading terms, okay? The terms with the highest exponent is what we're worried about, okay? And let me actually change this n up here to an m, okay? All right, and let me color code this too, just so we don't get confused between n and m. All right. All right. So we have three scenarios that we're going to talk about. We're going to have one where m equals n, which we see in this case right here, in examples 9 and 10. And then we're going to have one where m is greater than n. And then we're going to have one where m is less than n, okay? All right, so those are the three situations, three scenarios, and we'll see how those turn out, okay? All right, so, and this is another situation where positive or negative infinity doesn't matter except for this case right here. That's the only case where it matters whether you have positive or negative infinity, okay? These other two cases are independent. The results are independent of whether you're approaching positive infinity or negative infinity, okay? All right, so let's start with this one here. So I'm going to do a technique here, use a little bit of algebra. Let me just zoom in a little bit. Okay, so what I'm going to do is, we know that with a fraction, we can multiply or divide by whatever we want as long as we do the same thing on top and bottom, right? So this technique works with all of these, and you don't have to, I do want you to show this work. Anyway, this is work that you don't always have to show, but it's a good thing to show to get yourself partial credit, or at least kind of guarantee partial credit. If you get the wrong answer, you don't show this work, then you could lose all your points on a test or quiz question. But if you show your work and you make a computational error, then you could get some partial credit, okay? But what I'm going to do is I'm going to divide everything by x to the highest degree in the denominator, okay? So I'm going to divide everything by x squared. So I want to divide by the highest exponent, the highest variable expression in the denominator, okay? The variable expression with the highest exponent. All right, and don't worry about the coefficient, just the variable. All right, so what's going to happen is I'm going to have negative 15 x squared over x squared, right? And then I'll have negative 5x over x squared, and then I'll have 13 over x squared. And then at the bottom, I'll have negative 12x squared over x squared, negative 7x over x squared, and positive 11 over x squared. Okay, so I'm dividing every one of these terms. I'm basically distributing using division, right? So I'm distributing this x squared and dividing x squared by each of those terms in there. Okay, now here's where you'll kind of see the payoff a little bit, is as I cancel these things out, these go away, right? These go away. Here, x over x squared, one of those x's on the bottom goes away and the top one goes away. Same thing here. And here, nothing goes away, right? So what I end up with is negative 15 minus 5 over x plus 13 over x squared all over negative 12 minus 7 over x plus 11 over x squared. So let me reintroduce this limit. So I have the limit as x approaches infinity, right? And let's use our limit laws for a second. So we can use our quotient law and do the top separate from the bottom. And we can use our sum and difference law and do each of these terms separately. So let's just take each of these terms one at a time. So if I take 13 over x squared and I approach infinity, if I have a constant on top and a variable expression in the bottom, this is going to go to 0, right? Same thing with this. This will go to 0. This will go to 0 for the same reasons, right? Constant over x. As this number in the bottom gets super, super large towards infinity, it'll get, you know, a constant divided by that increasingly large number is going to get increasingly small towards 0, right? It's going to get to the infinitesimal level. So all this stuff is going to turn into 0 as we approach infinity. So all we're going to have left is negative 15 over negative 12, right? And we can reduce that to, if we divide both sides by negative 3, we get 5 over 4. Okay, so that's our final answer. So when the exponent, when the degree in the numerator is the same as the degree in the denominator, when we have this situation going on, what we're going to get is we're going to get a over b. Okay, so basically we'll just end up with these two as a fraction, and that's going to be our final answer, right? Simplified, of course, but that's going to be what we end up with. All right. So going back to showing work, once again, you don't have to show all this work every time. It might be good for you to show it a couple times in your practice just to kind of make sure you're understanding why it is what it is. But this is a good way to show your work too, is just show me that you're dividing by the highest variable, or the variable with the highest exponent in the denominator on top and bottom, and that kind of shows me that you understand the process and kind of how this comes out. Okay. All right. So go ahead and try this one now. So we're approaching infinity, but it doesn't matter whether you're approaching positive or negative infinity. This holds, okay? So it's, you know, we always know we're just going to get those leading coefficients divided by one another without any variables here, and that's going to be our final answer, okay? So try this one out and see what you get. All right, good. If you got so if we divide, this time we're dividing by x squared again, right? So if you got 12 over negative 3, and then you reduce that to negative 4, good job. And remember, all we're doing is just taking these leading coefficients, right? And just basically eliminating everything else because these are the same.